Okay, so today we will continue our discussion about performance evaluation and model tuning. Okay, and at the end of last class, what we discussed is you can also using learning curve. And the validation curve. For the performance evaluation, okay. And the learning curve is regarding the number of samples versus accuracy. Validation is regarding the hyperparameter values within certain range and the accuracy, okay. And what today we will learn in sklearn, there is another approach that can support us to do fine tuning. Okay, it's called grade search. Grade search. So before we start to take a look at grade search, there is another. And the previous, I remember in our lecture, I also mentioned. So in machine learning, the parameter, the two types. Okay, one that at the very beginning of the class we learned is it the parameter like weights. Weights they learned from training data. So that's one kind of parameter. Another type of parameter is we needed to optimize the parameter. And we call it parameter tuning, is it? And those kind of parameter, we call it a hyperparameter. Like the regularization C and the gamma. So those are called hyperparameter, okay. And so for hyperparameter tuning, we can use a grade search, okay, and sklearn has a module that support a grade search, okay. So let's take a quick look. And for the grade search, it's regarding tuning parameter, okay, so keep this in mind, regarding hyperparameter tuning. And it said it's a quite a straightforward concept, okay, and it's a brute force exhaustive search paradigm approach. And basically it's you specify a list of values for different hyperparameters, and then the model will evaluate for you, and then you can find the optimum one from this module. So previously what we learned is we can do ourselves. Is it for the hyperparameter, we provide the range and then run the model one by one, is it? But with grade search, then you don't need to do that. So it will take care of that part, okay? This says it's do the exhaustive search, okay, to find the optimal one. And the grade search is that its downside is the computation very expensive. Is it because we need to run a number of times? Is it try with different parameter? Is it? So it says an alternative approach is to do some randomized search. So in sklearn, it's called randomized search across validation. So CV previously we also learned is a cross validation. Okay, so this is regarding grade search. So next, let's take a look at our example, okay, regarding grade search. It's here. Okay, So let's see, grade search one. Yeah, if you recall last class, we learned the learning curve. The learning curve is number of samples versus the accuracy, is it? And then if both the training curve and the validation curve, the gap between them are quite small, and they are also approach to your desired ones, then that means the model is a optimal model, that in this case. And the other one is validation curve. Validation curve is regarding the parameter, you change the range, is it? And then you can collect the accuracy. Then you can find the best one, is it? Because like in this case, the gap between the training and the validation grow bigger. So that means when C is larger, it's not good. So the optimal one is within 0.01 to 0.1, this kind of range, it's good. And because it's also approach to the desired accuracy. Okay, so that's regarding validation curve. So tuning parameter, we can also use grade search. Okay, so for the grade search, then you need to import the grade search cross validation. Okay, you need to increase this model. And what we previously in our last class, we also learned the pipeline that it can, so that we don't need to do step by step. So it will pipeline for the feature scaling in this case, and this is model training. It didn't involve the dimensionality reduction. You can also add dimensionality reduction if the features are large. And so in this case, it's this pipeline just do feature scaling. And this SVC is support vector machine model. Okay, so it just do features and then go ahead to do SVM. And here we also provide some parameter range, as it for C, for gamma, etc. So we list the range in the list. And then over here, what we provide is a list of dictionary. Okay, so this is a Python list. And over here, you have a list of dictionary. Python dictionary, so we have the key and the value, key and the value, etc. And it's in a list. Okay, so for this part, it's regarding SVC, it's linear SVC. And for the second part, it's regarding the kernel SVM. Okay, and for linear one, you don't need to worry the gamma, etc. And for the, so this C is for the regularization, we already know, etc. And then we can just go ahead to do the grade search, etc. And then you supply the this pipe SVC is from the pipeline, etc. So that's our estimator. And then you can supply this grade. Okay, so we are going to try with different models here also. That one is a linear SVM, one is a kernel one. And then the score we are going to collect with accuracy. And it also supports cross validation, is it 10 folds here. And also multi, it support if multiple CPUs do the parallel processing. Okay. So after we have this great search model established, then you can start training. Is it training with the training data? Okay, so this is the training data. Then we can collect the score, and it also give you the best parameter. So the score we can see is quite high, 98%. Is it? And the best parameter it provides is, okay, regarding the regularization parameter, 100 gamma is 0.001. And it also, greater search over here is, you can see it also help us pick the best model, is it? So it use the nonlinear one, the kernel one, is it? Not the linear one. And what the next one try to do is, then you can also collect the testing score, is it? So after the greater search, is it? Then we can do, so over here, you pick the best model here from the greater search. You pick the best model, then you can start on the training data. So after the training data, we want to get the accuracy for the testing data, is it? So in this case, the testing data is around 97. So it's a pretty good, is it? Okay, and what is the next one? Let's take a look. Okay, the next concept is algorithm selection with nested cross-validation. Okay, and if you recall previously, we already used k-fold cross-validation, is it? And we also learned the greater search, is it? So if we combine both, then it's useful approach is that for fine-tuning the performance of machine learning model, is it? Because we can verify hyperparameter values. Okay. And then it says to select among different machine learning algorithms. It says another recommendation approach is to also consider nested cross-validation. Okay, for the nested cross-validation, so it nested, so kind of like a nested loop, is it? So then it's the outer key-fold cross-validation loop. Then it is split data into training and testing fold, is it? And then within it, within the training data set, we have an inner loop. And that inner loop is that going to use select model using k-fold cross-validation on the training fold. Okay, and after the model selection, then the test fold just used for evaluation, the model performance. Okay, so that's the general idea about this nested cross-validation. And if we take a look at this diagram, that helps us understand better, is it? So outer loop, in this case, it's already k-folds, is it? And we have the training part, is it? So for the training part, then you also do the training and validation, is it? And so this is the inner loop. So the purpose for the inner loop is to tune parameter. Okay, so be careful, it's to tune the parameter, hyperparameter. So tune hyperparameter. Okay, then for your training folds, is it? Then we have the testing part. So that part is used to what? For train with optimal parameter. Okay, So that involves the training, yeah, like find the optimal weights. Okay, so we can also combine both together, okay. So that's the idea. Then let's take a look at our coding part. How are we supposed to do that? So over here, if you take a look, so for the graded search, so we set up the graded search model. So the estimator is the pipeline, and the pipeline with the support vector machine, is it? And here is the parameter grade. So parameter grade, if you recall, is regarding C and the gamma, is it? And then you also provide what kind of scoring, because previously, if you recall, we also learned the other scoring, is that for performance metrics, it's not just accuracy. You can also using a confusion matrix, like precision, is it? Like those other measuring performance. And the false cross-validation is 2. Okay, so this is within the graded search. And after that, over here, we have cross-validation, and we can collect the score. And then for this one, you plug in this graded search, is it? And it's on training. And here the score is at its accuracy. Okay, and the fold is 5. So over here, is it? So we have this part is for hyperparameter. Parameter tuning. And then for this part is just do model parameter optimization. Is it like weights? Is it? Yeah. And so we combine both together, and then we can also collect the accuracy score, is it? So here we collect the mean value and the standard deviation. Okay. So that's regarding, we combine both together. And it gave us more example. We can also combine decision tree. Okay. So the graded search here, the estimator then is our decision tree. Okay. And for decision tree, then the graded search parameter, then it's the depth of the tree. So this is the depth of tree. Okay, random tree. Is it random forest and decision tree? So the depth of the tree is one of the important factors that are going to determine the model's accuracy. Is that so? Scoring is still using accuracy, and here is the cross-validation fold is 2, and then we do cross-validation. So for this cross-validation, we can collect the score. Then you just plug in this graded search with training. So nothing new here. Then we can find also its mean value and its standard deviation. Okay. So this is regarding graded search. And what next to try to show? Previously, if you recall, we already discussed the concept that regarding model performance measuring. Okay. Model performance measuring. And besides accuracy, we can also do confusion matrix. It gives us more idea. Confusion matrix is regarding true positive, false positive, true negative, false negative, is it? So it's gave us the score, etc. for what I just mentioned. So here, in this example, it's still use our previous the pipeline model for the training data, etc. And then we can do the predict with the testing data. Okay, and then the confusion matrix is on the testing data and the predicted data. Okay, then you can find the confusion matrix. Okay, so this is regarding confusion matrix. And the next just draw the confusion matrix. And what next one try to tell us is from sklearn, we can also direct get precision score, recall, and F1 score. Okay. So the model is you just need to get the precision score, recall score, and F1 score. Okay, and you plug in this testing data and the predicted data, etc. And then you can collect all of the accuracy, okay, regarding each of the score. And sklearn has another model called make score. And then you can specify whatever previously we just discussed, okay, like a recall score, precision score, F1 score, etc. For that, if you want to use, you just call make a score, okay, then you specify which score you want to use. And then over here, what it try to do is parameter tuning, etc. For the parameter grade. Then we can do grade search, etc. And still use the previous pipeline support vector model, okay. And then we plug in with the grade search. And within the grade search, then you can plug in the list for the hyperparameter values, okay. And over here, if you recall the scoring previously for grade searches, then you can specify which score you want to use. That's it. So here says, okay, I'm going to use F1 score instead of regular accuracy. So you can also specify, okay, which score you want to use. And then you can train the model, and then you can collect the score and the parameter, hyperparameter tuning. Okay, so that's regarding grade score, those concepts. And then what next one is, so we already learned all of this. What the next one is also a quite important concept in machine learning a lot of time. You will also see the plot receiver operating characteristic. Okay, so ROC graph. So what is ROC? It's called receiver operating characteristic graph. And this can also is as quite useful tools to select models for classification. Okay, based on performance. This is regarding what? It's regarding, this is the false positive rate. Okay, and the true positive rate. As this model is better, as this one is high, this one is low. As it is this one. And basically we can also graph the relationship between these two. Okay, and on this graph, the diagonal one basically is what? It's some random guessing. Okay, so if your curve is even under the diagonal one, then that's a bad model. bad model. Okay, so this is a false positive rate. This is true positive rate. So the best scenario is what? Is something like this. Okay, so suppose this is 1, and here is 1, this is 0, is it? So if your model's false positive rate is lower, is close to 0, but your true positive rate is close to 1, then that means your model is really good. Okay, and normally what's important is we also calculate the area under the curve. The area under the curve. Then the area under the curve is called what? It's called ROC, area under the curve. Okay, so it says we can compute this AUC, then to characterize the performance of a classification model. Okay, so that's the concept. And then next, let's see. Oh, I need to share. Hold on, let me, why I cannot find it. Oh, yeah, it's here. Okay, so regarding that ROC, is it, and so ROC and AUC. AUC is regarding the area under it, okay, under the curve. And what is ROC? ROC basically is to reflect the curve of the probability, okay. So let's take a look. And in the following curve, so we have some curve. So it says red distribution curve is positive class. Okay, so it's regarding the distribution of probability. Okay, and the green distribution curve is regarding negative class. Okay. Then let's take a look at the different scenario. Okay. Okay, so red is regarding positive classification. This is negative classification. Okay, so this is regarding the distribution. Possibility. Distribution. Okay, so here is the 0.5 threshold, is it? So in this case, we can clearly say the true positive and the true negative, is it? They have clear boundary. They have clear boundary. Then the respective ROC curve. So this is ROC curve, is it? So our true positive rate, when true positive rate is 1, then false positive rate is 0, is it? So it has a clear boundary. And the area under it, AUC in this case is 1. So this is a perfect case. Perfect case, is it ideal situation? Okay, when the two curves don't overlap at all, is it at all? So they have the clear boundary, okay. And then what the second cases is, if you take a look, then those two, so positive and negative, they have some overlap, is it? They have some overlap. So regarding this part, distribution is a false positive because it's basically should be negative, is it? And then in this part, it is a false negative because it's supposed to be true positive. So there's some overlap, is it? overlap, then the respective ROC curve then looks like this. Is it? It looks like this. So what we care about is the AUC. Is it the area under it? Okay. So definitely it's not 1. Is it less than 1? Okay. So that's this case. Then what the third case is both overlap together. Is it? Both overlap together, then the AUC is just 0.5. So basically the model has no discrimination capacities to distinguish between positive and negative. So this is kind of like if you do random guessing, you can also get kind of like this distribution. Okay, so that's not a good idea. And there is another one is the AUC. So it's a cross. The true positive go to the negative side, and the negative part, true negative goes to the positive side. Is it? Then the AUC. So it's completely wrong. Is it? Then it's 0. Is it? So basically, it's inverse your classification. Okay, so completely wrong. Okay, so that's just regarding this ROC concept. Okay, and then next, let's take a look at our code. Okay, so how do we get that ROC curve and AUC? Okay, so in sklearn, we don't need to worry too much basically here. It already gave us the module, okay, for ROC curve and AUC. Okay, we can directly get it. Okay, so this is for interpolation. Okay, and the make pipeline, nothing new. Is it just feature scaling? This is regarding dimensionality reduction. And over here, we use logistic regression, okay? And we also specify the regularization parameter. And after that, okay, for the training data, we are not going to collect all of the features. We just collected 2 features in this regarding, okay? And then what next we try to do is we also do the k-fold, is a cross validation, okay? And the folding is just 3 folds, okay? And then we do the split of the data, okay? And after that, what we do is, this part is we already discussed, okay? And what is the next part? We are going to do the plotting, okay? Do the plotting, and we are going to collect the true positive rate and the false positive rate. Is it? And all true positive. And because we have different folds, is it? So that's why over here it does a loop for each fold, because we do the k folds. We want to collect information regarding each fold, okay? And then for each fold, what we are going to do is, for our training data, we try to train the model. So this is the pipeline part for model training. And if you recall for ROC, that it's regarding the possibility distribution of the true positive and false negative. That those information, that false positive, true positive. So then you just call the predict probability. Okay, so you can collect the information, okay, the distribution. And then you just use this ROC curve module. With this module, you plug in what? With testing data. Okay, then you provide the probability distribution regarding true positive and false positive. Is it? So then it will give you the true positive, false, or true positive, false positive, and the threshold, if you recall previously in our explanation. Is it? Okay, so after that, then we can also collect the AUC with the true positive and false positive. Is it? Then we can do the plotting. Okay, and we can take a look at the plotting result. So here is a plotting result for each fold. Is it? We can clearly see for fold, and it also gives us the area. Is it? And it's not that high, but it's not too bad. Is it? Around 0.7-ish. Is it? And this is the random guessing one. Okay. And over here, it also shows the mean one, this black line one. Okay. That's the mean one. And the perfect should go like this. This is a perfect case. Okay. So this is regarding ROC. So we can also use ROC, AUC to help us, support us for model selection. Okay. So basically, we complete this unit study, and next Monday we will start with a new unit. Okay. And